fractions are one of the most challenging concepts for children to master in my experience. I believe that they need a lot of sensorial work, taking materials such as a fraction puzzle or the fraction stacker or metal fraction insets, tracing them, labeling them, exploring with using them practically for dividing up snacks, those kinds of things. By the time they start to move through these exercises, it should be very familiar with them, the idea of fractions, and now we're formalizing it. Now we're learning to associate names, and we're learning more challenging concepts such as the idea of numerators and denominators. So the first exercise from this little cabinet is fraction families. We call all of the fractions that have the same denominator, the same bottom number, we call fractions in the same family. So what they are doing with this first exercise, using whatever material that you have for their fractions, they would be associating the family names. Now, whole is kind of a family name, but mostly it's from the halves on through the tenths or the twelfths if you have a set that has 11ths and 12ths. So this is the halves family. It's the trickiest because it's not the seconds family. In English, we call the fraction family that has two members the halves family. It's kind of tricky when you're working with it in terms of the names, but if you've been doing a lot of practical experience and saying, oh, you know, when your mom gives you half an apple and gives your brother half an apple, this is where we get the halves family. Thirds, fourths, fifths, sixths, sevenths, eighths, ninths, and tenths. The children can record these. They can trace all of the members of the family and write thirds down below them. Remember, the more you involve the hand, the more likely the knowledge is to stick. So this is the first exercise of Fraction Cabinet A. The second exercise of Fraction Cabinet B introduces the numerator. You would at this point start to use these terms. The family name is the denominator. The top number is the numerator. So if I have 5/7, this is which family? Yes, the sevenths family. These are the numerator 7 or the sevenths family. But how many members are here? You can even talk about, oh, we have a large family here. We have a mother and a father that aren't here, and we have 5 siblings. So how many members of the family are present? 5. The mother and the father are missing, or 2 members are missing. We have 5/7. The family number, how many members are present. And in this drawer, all you have are the numbers and then a piece of ribbon or cord. You can seal ribbon or cord with nail polish, or if it is the kind that if you burn it, it will seal the ends, you can do that as well. So that's the fraction numerals. How do they record this work? They would trace these 5 members of the sevenths family, label the sevenths, and then write the 5/7, just like the fraction that they've built here. So this is the second drawer, and it is the numerators. Now, I will usually have a separate piece of work out where children can build fractions, and built onto the board it says numerator, says denominator. The reason that I don't have it here is that really is more of an upper elementary work typically. Depends on the children, how long they've been in the Montessori environment. Now, the third drawer is when we do quite a bit of work, and some of the children I have found do not want to complete this exercise, and if they are grasping fractions, I certainly don't require them to complete it to move on. The way that they do this is they label every single member of every single fraction. So what they would do if they were working with a fraction puzzle or the magnetic version of that, they would take out each one, place the numerals on them, trace them, and label them. So it is quite a bit of work, but it is something that some of the children really enjoy and need to do as well. Now, I am going to mention that especially when you have a work like this that has a lot of pieces, sometimes you're going to find that one got missing, or when you made the work, you didn't do it right. So if a child comes to you and says, Miss Susan, I only have 4 1/5, I don't have enough to do the work. Sometimes you just need to make a little correction on the fly. I like to keep sticky labels around where I can cut off a piece of the label and even do a quick fix like this where I just placed it over and then used a marker to write in the 5 so that we had the 1/5 card that we needed. Before we talk about the specifics of the next 3 exercises in Fraction Cabinet A, I want to take a moment to speak about why I'm doing this the way that I am. For some of you, simply looking at the layouts for these exercises will cause you almost immediately to understand how to use the material. One reason that I am not going through step by step for these videos is they are videos. If you don't understand it, you can play it again. And perhaps most importantly, the only way you are going to understand how to present exercises like this is if you pull the materials out and go through them yourself. Go through it yourself doing all of the exercises. So you take out all of drawer 4 and you do all the exercises. Then you take out all of drawer 4 and you present the exercises if you're going to present it to the children. Unless you do this kind of practice, you're going to find you're not going to serve the children the way that you need to. But I want to be respectful for people of all different abilities and all different learning styles, and not cause those of you who can take a glance and understand and be ready to practice to have to sit through a long explanation. So now, on to the specifics of these next 3 exercises. This is fractions to build. So we've learned to understand our fraction families. We've learned to understand what that bottom number is. We've learned that the top number tells us how many members of the family are present. So now we're checking our knowledge. What is 1/6? Well, of course, that's an easy one. You just pull out one of the 6th family. Then for 6/10, you pull out 6 members of the 10th family. Notice that I leave a little space after every set of 5. That allows the child to instantly see that quantity and move away from inefficient counting. And then, of course, we've got the 2/3. We've got, maybe 10 or 12 different fractions. Just make sure that all of them can be built with the fraction material you have. And I do like to contain things so that they don't get lost. So those little cards are in a tiny box inside of the drawer. Now the next exercise is equivalent fractions. Now this is very much a formalization of that fraction research that we talked about before. Now here you've got some options. If you're going to try and have the control of error that you have only as many lines as you can make with your material, that's going to be a little bit challenging when you get down to something like 1/2. I have not chosen to do that. So in the material that I am demonstrating with here, the only way to make 1/4 other than just a 1/4 piece is 2/8. If I had a material that went up to 12ths, obviously I could have 3/12 as another option. And the children would record this on their paper or in their math journal, and if they then knew additional pieces or if they wanted to do this with more than one material, those are all options. With this material, 1/3 will make 2/6 or 3/9. Now obviously with 1/2 there's a lot of options. 2/4, 2/4, 3/6, 4/8, and so on. So that's one of the reasons that would be you'd have to make your cards with a lot of spaces if you did want that control of error. At this level, I haven't found it's necessary. And then our third exercise in the cabinet is the beginning of working with our operations, fractions to add. You know, anytime you put 2 things together, 2/8 to make 1/4, you are adding. So this is where we're starting to formalize the simplest of operations that we've actually already been doing. And we're going to formalize it by writing it out. 1/5 plus 2/5 equals 3/5. Now notice the way that I have arranged the pieces for these problems. one of the things that I have run into is that children who have seen only problems that are represented in a horizontal fashion, addend, plus sign, addend, equal sign, place to write the sum, if they've only been exposed to that, the idea that the addends would be arranged vertically, addend, plus sign, addend, sum below, is very challenging for them. So sometimes I'll arrange things like this, especially if I run out of space on the rug, and I'll say, oh, this is one of our addends. It can be placed above the other addend or beside it. They still are all grouped together, so when I get my sum, I have 3/5. So I'm going to write 3, my number of family members, fifths, my family name or denominator. And I do talk about denom, the root of the word denominator is nom, which is name, and so that kind of helps tie it together for the children. Here we have 2/9 plus 3/9 equals 6/9, and 1/4 plus 1/4 equals 2/4. Now, there are children who at this point will say things like, oh, Miss Susan, that's the same as 1/2. And if they do, I say that's exactly right. You have simplified the fraction. Rather than having to write 2/4, you can just write 1/2. And if I'm writing it out in something like this, I write 1/4 plus 1/4 equals 2/4 equals 1/2. And so when they do make that leap, that's what I say. Now the last piece before we switch to the last set of exercise in this box is if I do have cards that have a rubber band on them, I teach the children to keep the rubber band at the corner of the rug, and that way they don't lose track of it. So when you take a rubber band off, you place it at the corner of the rug until you're ready to put it back on your cards. You may have heard me talk about second-generation Montessori math materials. These are math materials that have been brought into the Montessori classroom and are not part of the original set that Maria Montessori and her son Mario Montessori put together. I do believe that these have a place in Montessori classrooms as long as they are very carefully chosen. I do believe that it's very important to be very careful in bringing anything in to add to the original set of Montessori math materials, and it's especially important to be very, very careful before you substitute something. Take out one of the original materials and add in another one. There are two particular times when I think it's really important and really appropriate to at least consider adding in some of these new objects, materials. One is if that object can teach a math concept in a way that the existing set of Montessori materials really can't. The second reason is if that material is so attractive and is so attractive that it pulls the children into very Montessori math work that is sustained, that is concentrated, that is ongoing, I think it's worthwhile to consider those things to add into your classroom. And this object is one of those. This is the math balance from Activities for Learning. You may have heard me talk about their AL Abacus, another material that I think can have a very important place in a Montessori classroom. With the math balance, one of the things that you can do is give an understanding, a representation of equations in a way that you can't in any other way. Now, one of the things that I'm going to do here is just give a little bit of a sense of why I feel like this is important. I don't use this just all by itself, but one reason I'm going to talk about it without having out cards that I use or the little equal sign that I sometimes place right in the middle, right here, is because I do believe that having a chance to explore a material before you're given specific ways to work with it can be really, really vital. And this is one of those things. That's not the traditional way with Montessori. It's kind of, here's your presentation, especially with the math materials. Here's your presentation, here's the steps, here's how it's used. I believe we need to broaden that a little bit, and this is an ideal material to do that with. So what I do when I initially present this to children is I just help them to understand what we have here. This is just like I am putting a 1 on my balance if I place it on the 1 spot. But if I take it off and I place it on the 3 spot, it's not a 1 anymore. And if I have math beads in the classroom, if I have the traditional Montessori math cabinet or even just a single bead stair, I will bring the bead stair over and have a 1 and a 2 and show the child. So when I put this on here, it's just like the 3 bead bar. If I have Mortenson or Matthew C materials in my classroom, I'll bring those bars over and say, when I put it on here, it's just like this little blue 5 bar. When I've placed it here, this is 5 units. So that is the way that I help the children understand the way that the math balance works. So when I put it here, it's a 5. When I put it here, it's a 1. That itself is a little bit of a complicated concept. But if the children are at the point where they have mastered the quantities from 1 to 10, they should be fine with it. They need to have a very strong working knowledge with the numerals and the quantity associated with it from 1 to 10, and then they're ready for this material. So then what I'll do is I'll place this on here, and depending on the child, I might say, where could I place this on this side so it would be the very same thing that I've done here? And that's pretty simple. I'll just put it over here on the 1. Not always, but that's pretty simple. So now what I can say is, look, these things are equal. Whenever the math balance is in a nice straight vertical line, and mine did have some little weights so that if it's not exactly vertical, you could kind of correct it. Those are long gone, but it's close enough, because you'll see if I even place this at 2, you see a very different line that is created. So I can say this shows that 2 equals 2. And then I just let the child work with it, because typically they'll start doing some things like putting a couple of things on here. And if they do, I might say, oh, you've placed 2 quantities of 2 on this side of the balance. How would you make that equal? And they might place 2 quantities of 2 on this side of the balance. But of course, depending on where they are with their understanding, they might also place it on 4. And the last piece that I'm going to mention in this segment with an introduction to this material is that this is research. This is math research. If a child is seeking all the different ways to equal 8, that is research into 8. But the reason that I believe that this is a really valid, essential material is because it demonstrates in the way that I have not seen anything else do the idea of equality, which is an absolute essential skill to understand how to do equations. If you don't understand that when you have that equal sign, everything on this side of the equal sign must be the same in value as everything on this side of the equal sign, your work with equations is never going to be at a level of deep and complete understanding. In this segment, I'd like to give you a little bit of an idea just how far children can take work with the math balance. As I mentioned in a previous segment, the reason this is a key work, the reason I believe it deserves to at least be evaluated as a potential second generation math material in your Montessori classroom, is because it demonstrates the idea of equality in a way that almost nothing else does. And certainly it's been very, very effective in the classrooms that I've been in. So if I place a 2, I've of course in the previous segment shown how I introduced to the children the idea that when I place one of these on here, that's 1, 2, just like it was a 2 bead bar or a 2 Mortenson or Matthew C math bar. If I have 2 plus 5, that equals 7. So I have put in a concrete format the math equation 2 plus 5 or 5 plus 2 equals 7. Now, I purposely showed you that with my sum on this side. I do believe that it can be valuable to show with the math balance the typical sequence of the equations that we do, where we start with the add-ins and we're moving in this direction to get our sum or our factors in our product. But equal is not one directional. So you're going to find, particularly if your students are responsible for demonstrating mastery of the Common Core math standards, that they've got to be able to manipulate this around. They've got to be able to do an equation that is something like a blank box equals 2 plus 5. That's the kind of thing that they're going to have to be able to do. This is also an amazing material for demonstrating that we have the property, the commutative property. 5, if I put the 5 on and then I put the 2 on, it's still 7. If I put the 2 on and then I put the 5 on, it's still 7. And of course, if I were doing something like that, I would be writing those equations out at the same time. So the other piece that I want to show before I talk about math research with this is that this material can be used for the most basic multiplication problems as well. If I have 2 sets of 4, that equals 8. If I have 4 sets of 2, that equals 8. Now, are you seeing also how even if I'm not saying this, even if I'm not teaching the properties of these operations, this material just naturally puts those concepts into the child's mind by working with it. If they just explore how many different ways can I cause this to balance if I have an 8 on this side, a lot of amazing things can happen. Now, I would encourage you to play around with this. Okay, so we've got 3 times 3 equals 9 over here. I would say, rather than making sure that you have cards that will only, that the equations on your cards will only work for this material, and so you've got it kind of set up where the child will succeed in the multiplication problems or the addition or subtraction problems that you're giving them, take more of a research approach. As I've mentioned before, if I place a 10 here and then I figure out all the different ways that I can place weights on this side of the balance to create 10, that is research into 10. And the way that I would record it is just like this. 10 equals 10. And certainly for this, I would have my little card with an equal sign here. 10 equals 10. A lot of children know their doubles, so this might be the next one that they would come up with. 5 plus 5 equals 10. 1 plus 9 equals 10. So they are recording their research into 10. And again, in the spirit of discovery, you might find that they do something like this. 3 plus 3 plus 3 plus 1 equals 10. They're doing multiplication. They've now done for a very young child, a complex equation. 3 times 3 plus 1 equals 10. And you could show the children that were ready for that kind of recording. I encourage you to have these kinds of math materials in your classroom. I can very much attest to the fact that this material draws the children's interest. And it doesn't draw their interest simply to pull it off the shelf, play with it, and put it away, or just kind of figure out how it works and put it away. Even though I have noticed that if a child is not very comfortable in writing, the quality of work that they're able to do with this material isn't as high as those who are at least comfortable writing the numerals and just the simple signs, the plus sign, the equal sign. Even those who are not able to do that, I've seen do some very, very deep work that has helped their understanding of operations. And the children who are capable of just competently writing these numerals and those basic signs do some amazing pieces of work. If you're looking for ways, congruent Montessori ways, to expand the children's understanding of math, to get them ready to demonstrate competency on those Common Core math standards, I encourage you to look at some of the second generation Montessori math materials, including the Math Balance.